good evening. Is it Bhargavi? Yeah, I will speak to later. I sent you message just to attend that class if you want. Okay, it is on membrane technology. Now okay. Hello. Welcome to iiocs.com Food Tech Club. Today we will learn about membrane technology. So membrane technology is one of the technology which is used in food industry. So here you can see the plant also how it looks, and these are the instruments where it is used. These are the membrane modules where the this separation will occur in different layer membranes will be there. So there will be a separation will each step it can be occurring. So these are the equipments where it is used. So here you can see the membrane. Okay, so these are the kinds of the equipments where in the in membrane technology it will be used. So it is one of the beautiful technique. Now we'll understand what is the meaning of membrane technology and where and all it will be used, and its importance, and in the membranes means what is it is composed of, and all we will look into that one. So we know that the membrane technology is a transport of substances between two fractions with the help of permeable membrane. These are the some permeable membranes will be there. So there is a transport of substances between two fractions with the help of permeable membrane. So this covers all engineering approaches. So whatever the technology is there, it covers all engineering approaches to for this transportation. And in general, the mechanical separation process for separating gaseous and liquid streams use the membrane technology. So some gases also it can be separated, and liquid streams also. So two things it will be separated by means of this membrane technology. So here also the you can see the how the water treatment will be carried out, and the principles of this membrane separation is here by means of the driving force, the phase 1, and it will be the feed, means they will feed. Here you can see this is the membrane module. So different membrane module will be there. So what is passing through the membrane, that is called as a retentate, and what is which is not passing through this membrane, that is the permeate. So once we are feeding, it will be that fraction, it is a separation between these two fractions. Okay, so that is what here also you can see different color, means it is composed of different thing, but we require only the these only one fraction it is required, means through this membrane module the it will be separated. So membrane, it is a physical barrier from the from semi permeable material, and it allows some component to pass through while other are held. This will be held back and this will be passed through. Which is passing through, that is a retentate, and which is held on, that is a permeate. So here many of the in membrane separation, it may be by means of microfiltration, ultrafiltration, reverse osmosis, molecular sieving, gas separation, membrane contactors. Okay, so many of these will be there. So the principle will be the same. So here membrane module will be there. So by means of the driving force, the separation will be carried out. The flux selectivity will be there. So this is also the picture which shows the principle of the this membrane technology. Here you can see the color, which is in this color will be the filtrate. Okay, filtrate, and it is the this green is the medium for the squeezing. It is squeezing out. Okay, here you can see the filtrate is coming out. Okay, so and filter cake, this will be the filter cake, and the red color will be the filter cloth. So this is what the how the squeezing will be occurring. Here this is the membrane module. You can see how the different product water, okay, and the waste water will be entered through the membrane. So the product water collection material and membrane, these are the membrane for separation. Feed channel spacer is there, and perforated central, these are the tube, and brine seal. Here the water will be entering, so the product water will be remaining. So remaining also how the effluent will be. These are the membrane. Okay, this is the feed channel spacer. So this is the what the tube, the first picture what I shown na. So this is the inner division of that one. So because because of its multidisciplinary character, membrane technology is used in several industries, including water treatment for domestic, industrial water supply, chemical, pharmaceutical, biotechnological, beverages, food metallurgy, and other separation process also. All these things here, this membrane technology is used, and it is probably membrane technology is known for its water treatment. In water treatment and also in public sector link membrane primarily to sea water. Okay, so desalination. Okay, desalination has to be salt. In case of sea water, so desalination is the salt has to be removed. So that will be by means of membrane technology. So this is what, and also in United States it is used to desalinated blackish water to remove the color and also to particulates, some of the and hardness of the water can be removed to remove turbidity, bacteria, viruses. So for all these things the membranes are used. So in that way the many of the applications we can see, maybe in the food also, dairy, beverages, in fruits and vegetables, every day in the industry it is used. So some of the applications we can see here: microfiltration for the removal of the bacteria spore, removal from the skim milk whey and WPC. Okay, and microfiltration and ultrafiltration to for the protein fractionation. So different proteins will be there, that has to be fractionated. So by using the microfiltration and ultrafiltration, proteins will be fractionated. And microfiltration for delipidization of whey. Okay, delipidization of whey, and also lipids can be removed, and microfiltration, the chemical recovery also it can be used. Ultrafiltration is used for the concentration and fractionation of the proteins in the milk, and ultrafiltration for brine clarification. Brine, we know, salt. Okay, the salt solution. So in that, if more amount of salt means it will look like a cloudy turbidity, so it has to be clarified. So for that also ultra filtration, nanofiltration for demineralization of the ultrafiltration permeate. Nanofiltration again, demineralization of the whey. And for nanofiltration, milk electrolytes. Reverse osmosis, it's for the water removal from the whey and other streams. So water has to be removed from the whey, means more amount of water will be there. So by means of the reverse osmosis it can be done. So these are the some of the applications. So now we will understand the terminals, means some of the things we will be using here. So just now I told na WPC, that is whey protein concentrate. So WPI, that is whey protein isolate. So like this MFM, that is microfiltration, UF ultrafiltration, nanofiltration, RO reverse osmosis, TMP is transmembrane pressure, CF is a cross flow, DF will be diafiltration, UTMP, that is uniform transmembrane pressure, NPN non-protein nitrogenous. These are the abbreviation where we will be come across in this study. So ED will be electrodialysis, and MFGM is milk fat globule membrane, LAB lactic acid bacteria. So and these are the terms we will be using. So this membrane processing technology is increasingly used nowadays for the demineralization, desalination, stabilization, separation, deacidification, and reduction of microbial load, purification, and also clarification in case of the fruit and vegetable juices. In food industries like that, it will be used in a wide range. The most frequently applied techniques are electrodialysis and reverse osmosis, nanofiltration, ultrafiltration, and microfiltration. See in the picture you can see these are the things which are used. Okay, membrane. So reverse osmosis, how the salt water will be converted into fresh water by means of the reverse osmosis. So by using the pressure, so here you can see salt molecules will be retained and only the water molecule will be passing through the membrane. So here also you can see the how they are holding the membrane, how it will looks. Okay, so this is what by using these membrane and the hydraulic pressure, so it will help. So several membrane characteristics like pore size will be different, flow property will be different. Okay, and also the applied hydraulic pressure, it will determine the membrane's potential, how much it is potential membrane. In this is also the water, the clean water, if we want get by the disinfection, it will be happening, and decontamination will happen and it will give the clean water. Desalination will be they are doing and we will get clean water, and reuse and reclamation, then we will get the clean water. These all the things can be done by this is the filtration, microfiltration, ultrafiltration, nanofiltration, finally reverse osmosis. Here you can see these are the raw water is it is so raw water is passing through all these membranes. How we are getting permeate? So these are the micron size. Here is the microfiltration, that is 10 to 10 to 0.1 micron, and the pressure, transmembrane pressure will be, this membrane pressure will be 0.2 to 5 bar, and here you can see the these suspended particles, these are the oil emulsion, and these will be the bacterial cells, and the colloidal haze will be there, and some are the viruses will be there. So by means of microfiltration, what we will get, these what it will be retained, the picture will tell only suspended particles will be retained and some will be coming inside. Then again ultrafiltration, by means of ultrafiltration, here some will be retained, again it will be we are getting. So finally like this only, ultrafiltration, nanofiltration, finally reverse osmosis, and we will get the clear clean water, that is the permeate. Okay, so all these submolecular organic groups, monovalent ions, divalent ions, protein, macromolecule, viruses, bacteria, everything will be, it will be removed, and only the water we will be getting water by means of finally reverse osmosis. And also in case of tea also you can see the tea leaves, how the raw material juicing will be done, and extraction with the water or solvent also will be done. Okay, so this is what the tea, how we will be getting is by means of the ceramic membrane, the filtration will be happening. Here you can see D polyphenols and polysaccharides. Okay, and by means of the reverse osmosis you will get theanine and theanine. So and ceramic membrane, by means of this reverse osmosis you will be getting the, see here the tea drinks will be there, and also instant tea, and you will get mixing liquid and can filling by means of this membrane technology. Ceramic membrane is used. Here also you can see the picture how the molecules are entering through the membrane selectively. So only the selective molecules will be passing through the membrane, separation is happening. Okay, so this is what molecular level, the separation we can see in the picture. So now we will understand the membrane characteristic. So it is the table which will tell the process, different processes, and membrane type, what is the type of the membrane and pore radius, and also the what material is used in the membrane, and also how much process driving force is used, and its application will study. So in case of the microfiltration, the membrane type is symmetric microporous. It is like symmetric microporous. The size will be 0.1 to 1 microns. And membrane, what type of material is used? Cellulose, nitrate, air, acetate, polyvinylidene difluoride, that is PVDF, polyamides, polysulfone, okay, and PTFE, metal oxide, etc. are the membrane material in case of microfiltration. In microfiltration, the driving force is a hydrostatic pressure difference about the 10 to 30 psi, and the application is for bacteria and cyst filtration will happen, and clarification will be is the application, potable water treatment, and reverse osmosis pre-treatment. It is a pre-treatment of reverse osmosis. And ultrafiltration. In the ultrafiltration, membrane type is asymmetric microporous, and the size will be 0.001 to 0.1 microns. Here the membrane material is polysulfone, polypropylene, nylon 6, acrylic copolymer, and the pressure driving force will be like hydrostatic pressure difference at approximately 30 to 100 psi, and the application is for the separation of macromolecular solution, reverse osmosis pre-treatment, again as in the picture already it is shown, last reverse osmosis, correct. So this is what the reverse osmosis here also asymmetric skin type of membrane is used. So this much of the angstroms, 5 to 10 angstroms size. Here the material will be thin film composite, cellulose acetate, aromatic polyamide. So these are the material of this membrane, and the pressure will be of about 200 to 1000 psi hydrostatic pressure. So it is reverse osmosis for the separation of salts and microsolutes from the solution. Nowadays reverse osmosis, whatever the salt, the water is not good, like that many articles are coming. Reverse osmosis is it is why, because here what is they are doing, separation of salts. Some our body requires some of the salts, that also if that is removing, then okay, that is because of that joint pain and all, it is, that is what research is they are doing, how much we should, and reverse osmosis if we are doing, what and all the salts to be removed and what and all salts to be retained, that we should always, we should have the conscious, because that is required. And electrodialysis, in electrodialysis cation and anion exchange membrane and sulfonated cross-linked polystyrene membrane is used. Electrical potential gradient, by means of electrical potential gradient, that is only acting as a driving force for the separation, desalting of ionic solution. And gas separation, see what the gas, separation of gas mixture, how nicely the gases, liquid, okay, we can little bit we can think of in the liquid also it is but gases also, how nicely that here the membrane is polymers and copolymers. Here the hydrostatic pressure and concentration gradient only, by means just concentration gradient, we know that always it will move from its higher concentration to its lower concentration, that is the concentration gradient, by means of that it will be happening. In case of nanofiltration also, thin film membrane is used, that is TFC is the material name, and 50 to 150 psi, and removal of hardness and desalting, nanofiltration. Okay, so these are the things. Here also some of the same thing, little bit some extra thing will be there. So these are the plants where the membrane technology is implemented. See how nicely it will look, and it is very efficiently it is happening. And we can see in the Bangalore also, near the Kengeri, the big plant is there where the wastewater treatment is done. So just like this only it will be looking. So these are the, you can see in the urban places in city. So this is and all important for wastewater treatment also. Okay, so here you can see the types of membrane and its characteristic as we already understood. So just you can see the picture, microfiltration, what and all it will be passing through and what will be retained. And in case of ultrafiltration also, so nanofiltration also, so what will be retained and what will be passing through the membrane. Reverse osmosis, only water remaining, everything will be retained. So we will get the only water by means of the reverse osmosis. So these and all the pre-treatment of the reverse osmosis we can tell. Okay, so this is the use of membrane technology as processing and separation method in food industry, it is gaining wide application. So it is a alternative techniques or novel technology for the processing of the new ingredients and foods. So we can consider it as a green technology. Why? Because no heat and no pollution, so good technique it is. So we can call it as a green technology. So in many cases membrane processes are more advantageous than the traditional one. For example, cold pasteurization, sterilization with stable membranes instead of a high temperature treatment for the removal of microorganisms. It is the more economical in terms of energy consumption also, this membrane. So using membrane filtration to remove the microorganisms for shelf life extension of the foods instead of using the additives and preservatives. Okay, we can avoid using the additives and also the preservatives, because here by just by means of the filtration, membrane filtration, we can remove the microorganisms. So this is what because of this we can avoid the additives and preservatives. And concentration also, way concentration, where the plenty of water will be there, so we require much amount of the heat for concentration, so that also can be. So instead of thermal evaporation, so here by means of the membrane technology, we can concentration can be achieved, and also the nutritional value also retained. The heat sensitive components will not be it will not go into loss, it will be retained. So these are the these and all the pressure driven membrane process, like the microfiltration, ultrafiltration. Okay, these and all are the, so based on the this is separation of the components with large range of the particle sizes, based on the particle size, molecular size, so it will be happening. Because of this reason only the valuable bioactive molecule can be retained, so it is having a wide application in food processing industry. So so we have to understand, when we feed the when we are feeding the material to the membrane separation system, it is separated into retentate. That is something, means whatever it can be, retentant can be called as a concentrate, and fraction that is retained by the membrane and permeate is also called as a filtrate. Okay, permeate is also called as a filtrate. It is the fraction that passes through the membrane. Okay, and retained is the fraction that is retained by the membrane. Okay, it is retained by the membrane is retentate, and permeate means it is a filtrate. And retain, both, any cases, maybe we sometimes we may require both the things, and sometimes only we are concerned, our desired material will be concentrate, sometimes our desired material may be the filtrate. So it is all depending upon the our requirement and the product. So the product of interest can be either be retentate or in the permeate. Okay, filtrate or concentrate, both may, in the both streams we may be interested. So the pressure driven, it means that the main driving force of separation is the transmembrane pressure. It is a transmembrane pressure, which is the pressure discrepancy between the retentate sides and permeate side. So generally speaking, the pore sizes are molecular weight cutoff in the cases of nanofiltration or reverse osmosis. Okay, the membrane decreases in the order from the microfiltration to reverse osmosis. This is what in picture also we have seen. So the pore size, the separation principle is not on pore size alone. Okay, that we have to, it is not the pore size alone, especially in case of the ultrafiltration, nanofiltration. The charge of the molecules or solutes and their affinity for the filtering membrane is also important. Affinity towards the membrane and as well as charge of the molecules. Okay, so both are important. So microfiltration is normally used for separation of the suspended particles and microorganisms from the soluble components. Ultrafiltration, it is for the separate to soluble macromolecules such as proteins and peptides. Ultrafiltration, these things we have to remember. Microfiltration for suspended particles and microorganisms, ultrafiltration for the soluble macromolecules such as proteins and peptides, nanofiltration, it is demineralization, and same time the concentration also. Okay, so nanofiltration also allows the monovalent salts, and operational transmembrane pressure values, it will increase from the microfiltration to reverse osmosis. Okay, so microfiltration in this transmembrane pressure is rarely more than higher than the 3 bar, and while the ultrafiltration normally it ranges from 3 to 7 bar, nanofiltration 10 to 30 bar, reverse osmosis membrane theoretically allow only water to permeate. So this means the RO process works against the chemical potential difference, namely osmotic pressure. Okay, so here by means of that, in the reverse osmosis, it will reject the 95% of the sodium chloride. So here the 10 to 75 bar pressure is higher, the pressure is in case of the reverse osmosis. Okay, so the because of this one only the water will be separated. Here the pressure is less, the maximum pressure is reverse osmosis. So now we will understand the membrane characteristics. So how the membrane will be there, we will understand its characteristic. Always the selection of suitable membrane is very important to get the success in specific application. So this filtering membrane is, it can be made from organic, polymeric or inorganic material. See, organic membranes are generally available in wide range, maybe based on pore size, and also it is cheaper, and normally the high packing density, that is high membrane surface area will be there, and unit space volume. Among the disadvantages of the organic membrane is, this is depending on the materials. It can work only on certain ranges of the temperature. Organic will work maybe the pH specific and transmembrane pressure. It work on certain ranges of temperature, pH, transmembrane pressure, certain range only. So organic membrane are more sensitive to wash, for washing also and chemicals also. Opposite to this one, inorganic membranes. So these are made up of with the ceramic material. So it can be operated in more extreme conditions, and it will have the longer service life also, this inorganic. So but they are more expensive than the, and also the packing capacity is low. Some like these advantages and disadvantages will be there. So these ceramic membranes are normally fabricated into tubular modules, and now it is available for microfiltration and ultrafiltration, and also these membrane materials are divided into hydrophilic and hydrophobic membranes. So depending on the properties of the feed, a suitable membrane should be selected. For example, to filter the aqueous solution of the proteins at a neutral pH, the hydrophilic membranes are considered to be more advantageous over hydrophobic ones. Since negatively charged proteins are more repulsive against the hydrophilic membranes, which will resulting into a less occurrence and lower extent of the membrane fouling. Okay, means this is what hydrophilic and hydrophobic. Okay, so the selectively the membrane will be selected. And now we will understand the membrane modules. So the word module, that is how membranes are arranged or packed, that we have to understand. Membranes, we know that what and all the material. Now how these membranes are arranged, there are several types. Okay, like plate and frame, or tubular or spiral, I shown you, or it is hollow fiber membrane cassette. Okay, all type of we shown in the picture. So different type of modules are different in packing density, and also the possible application will be different and prices also be different. So hollow fiber and spiral wound module provide the largest packed membrane area per unit volume, and while plate and frame and tubular module have the lowest packing density, which means highest investment for a unit membrane surface area, and tubular modules ceramic membranes. Okay, as I told, tubular module in microfiltration of the skim milk. So with this type of module, the feed channel is wide, example from the below 1 centimeter to 3 centimeter in diameter. So the feed can be pumped with a high cross force velocities, which help to minimize the formation of concentration, polarization and external membrane fouling, means the spoilage will be less. Okay, the and also spiral wound modules also, that diameter ranges from 0.1 to 2 mm, so less. Okay, and most common design for the it is RO and ultrafiltration spiral wound membrane. You can 0.1 to 2 mm, so thin. So application of membrane in food processing industries, as we are already discussing. So this is for the separate chemical components based on the molecular size under specific pressure. A great advantage of the membrane processing technique is that it is non-thermal processing technique, which can retain enormous bioactive constituents. Okay, so and also less energy intensive process it is. This technique is widely used in several food processing industries, such as in the clarification of the fruit juice, wine, concentration of milk. Okay, so clarification, fruit juice, if it is very clear, then it will look very good and it will be attractive, wine and all. And okay, whey protein concentrate, wastewater treatment. So all these are the applications. So in introducing this technique mainly to get the quality product. Okay, so it deals with the retention of the antioxidants by using this novel membrane processing techniques, and also whey processing, it will be helpful, degumming, dewaxing, decoloration of the edible crude oil. For crude oil also, so nice, the whatever it is, no oxidation will happen, and it will be helpful in wastewater treatment also. So now in the industry, as I already mentioned, deacidified, clarified fruit juices, by using the integrated membrane technique, it can be used, and separation and fractionation of the milk fat globule, removal of microorganisms, and fractionation of the milk proteins for making cheese, casein, whey proteins. It can be for the by means of these proteins can be concentrated. Treatment of the whey for the production of whey protein concentrate and protein isolate, also isolation of milk fat globule membrane materials, wastewater treatment. Okay, so this is what there are, these and all the uses of this membrane technology, so that we will get the better quality products in terms of the both technological functionalities and nutritional value. So we will get very good ingredients, and it is a favorable characteristic by means of this conventional techniques, and also it is the very good performance. We can see these and all the uses of the membrane technology in food industry. So the treated water, it is the key ingredient in the beverages. So the mixture of sweeteners will be there, minerals. So those total dissolved solids that will be treated by membrane system to achieve the required taste and nutrition composition. Okay, so that will be helpful. And also soft drinks, companies what they will be doing is the water. So water, they will be treating locally sourced water to produce a stable and consistent product with a good shelf stability, low turbidity and great taste. Great taste. So this is what you can, why the soft drink will be. So because of this membrane technology, this is what they are carrying out. Minerals and all they will be controlling. And okay, so high level of calcium and magnesium in source water can precipitate, leading to cloudiness in the finished product during the storage. And many of the soft drinks, so they will be actually, this is what I was telling, in reverse osmosis these calcium and magnesium are required. Okay, these soft drink people, what they will do, they will be removing this one because the cloudiness will be appearing in the finished product. So after storing it will be occurring, so they will be removing. Same in case of the reverse osmosis also, certain amount should be there. Okay, certain amount of these minerals should be there. If we are removing, that is not correct. So many of the soft drink bottling facilities use the membranes to treat the locally available water to a high standard before blending in the syrups and carbonation. This is what they are doing, so to get the great taste and also get the correct clarified soft drinks. So similarly in beer brewing, it is also the consistent water quality they want for the final taste. For that also they will be, so brew masters will be there, they will be monitoring the water quality. So by means of the membrane technology, this is what. And the brewery waste waters also, so BOD, biological oxygen demand, and byproducts, sugars, proteins, carbohydrates will be there. So that will be again it will be extended for membrane bioreactor reverse osmosis system to reduce the wastewater discharge. Okay, so like this the waste can be, so this is the green technology where it is avoiding the pollution also, and so nice it is, it has to be implemented. And the dairy industry also, the valuable large variety of the treatment, ultrafiltration, microfiltration, okay, and in the removal of the bacteria, separation and fractionation of the components will be carried out. And milk can be disinfected by removing the bacteria and also viruses by means of the microfiltration and ultrafiltration. So boxed aseptic milk products now possible using the membrane. See, aseptic milk products just by using the membranes, milk and whey protein. So good it is, so much energy will be saved. And also it is treated for the separation, means thermal degradation will be avoided. And also cleaning and sanitization is very difficult part in dairy equipment. Okay, so that is also little bit, it will be different in case of the membrane system. And the cheese processing uses the membranes for treatment of the whey to produce and various whey protein products. Okay, so the valuable new revenue stream is there. Whey and milk concentration is achieved with the membranes, as is the demineralization of the whey for the protein recovery. So other than this one, the skim milk and also used for by nanofiltration and concentrating the lactose. Enzyme also play a major role in food processing. So two typically produced during the industrial fermentation. So where the microorganisms such as yeast and bacteria also it is used to produce the different kinds of enzymes. So microfiltration will help in the removal of microbial cell from the fermentation broth, because too much of fermentation, too much acidic, so it has to be removed. So nice. So maple sap also collected in the from the trees, so it will contain 2% of the sugar. So it is also converted into syrup by boiling out. Traditionally it used to. Now maple farmers, these are embraced reverse osmosis and nano filtration to concentrate the sap. Okay, then they will get 17 to 20 degree bricks without boiling only. Okay, so this is what very nice it is. Maple syrup and all, very good flavor and very good for health also. And in biscuits and all, it is it can be used. Maple syrup in confectionaries also it can be used. So these are the things where the for the BOD high, treat the high BOD wastewater. For that also in Japan it is installed, and like that total dissolved solids. So it is useful for not only with the food thing, it is other than for the wastewater treatment is very good. And the facilities for processing in case of vegetable, variety of the fruits and vegetables which is produced such as potato, carrot, apple, onion, lettuce, beets and bananas use the membrane for wastewater treatment. These and all. Okay. So in case of the municipal wastewater treatment also, and to get the higher the quality juice can be achieved by using the membrane technology. Apple, citrus, cranberry, cherry, grape, pomegranate, carrot and other juices are clarified. These and all are clarified by means of ultrafiltration and microfiltration membranes. Because of the clarification we will get clear juices. If it is clear, definitely the shelf life will be longer. So always uniformity will help in increasing the shelf life. So reverse osmosis is successfully it is used to remove the water and concentrate the juice, and reducing the transportation cost also. If you are concentrating the juice, you will get many concentrate juice in the market, so that they will be using whatever it is available in the fruity and maza and so many orange citrus juice also, they will be using the concentrate. So these concentrate juices will be preparing by this membrane technology. So membrane system typically require a less labor and maintenance than conventional treatment methods, and it can be easily adjusted to accommodate different feed juices. So a combination of resin membranes process can reduce the bitterness of some citrus juices such as orange, grapefruit, tangerine, lemon and lime, enhancing the juice quality and consistency and yield. Okay. So the wine production also it can be used. So color, ethanol, flavor and aroma components can be maintained. Tubular membranes have been used for the treatment of the juice lees and the solid that remains after the grape crushing. The wine lees the insoluble sediments in the wine processing for the recovery of the juice and wine that would otherwise be lost. So these are the tubular membranes are used for heavy metals residuals removal also. the membrane is used, and removing the total dissolved solids also. So these are the uses of the membrane technology. So cost wise, it is very advantages are there, membrane technology, and it is very attractive and alternative to this also. So by this I will end for the today. So goodbye for today. For any enquiry you can call to the number which is available on the screen, and so we'll meet again on this platform. So hope you will continue your preparation with iiocs.com. Thank you.